Okay, welcome back. So in this problem, we've got a guy who's going to be throwing a ball straight up into the air at 60 kilometers per hour. The question is, how much time will it take for the ball to come back down? Now, in order to do this, we aren't really given a lot of information. The first thing I'd like to do is change this 60 to meters per second. So I'm going to go 60 divided by 3.6 again. Once again, reiterating, kilometers per hour is the bigger number, meters per second is the smaller number, so therefore I have to divide by 3.6. So 60, enter, 3.6 divided by is 16.7 meters per second. Now, which equation am I going to use? There's a couple of different ways of doing this problem. If you realize that the time to rise is the same time to fall, then you could find the time to rise and double it, and you'd be correct. But there is another way to do it. Let me show you how. The other way is using this equation, delta D equals 1/2 AT squared plus VIT. Now in this case, what we're trying to find is T. Now you might be a little bit concerned here, because you might say to yourself, uh-oh, is this going to turn into a quadratic equation? It very well might. However, because our delta D is 0, because you see, even if this is the original position of the ball and the ball rises to some height and comes back down, it's going to come back down to the same height. And so therefore our delta D is going to be 0 vertically. Hence, if we say 0 equals 1/2. Now, what's A? That's G, which is going to be, say, negative 9.8 meters per second squared. And oops, I think I made a boo-boo there. The A is not squared. Let me erase that. And the time, well, I don't know what the time is. I'm just going to put T squared. Plus VI. Now, initial velocity is 60 up. No, sorry, not 60. I made a mistake here. That's the kilometers per hour number. We calculated that to be 16.7 up, and now multiplied by time. Now, if you notice this equation, the only variable that I don't know is time. However, what I can do is I can divide the whole thing by time. If I divide 0 by time, and this by time, and this by time, well, look what happens. This just ends up being 0. This square cancels that one, and this cancels that one. So what do I end up with? I end up with negative 4.9 T plus 16.7. Now if I solve for T, I'm going to get negative 16.7 divided by negative 4.9 gives me T, and my answer is 3.4 seconds. So it's going to take 3.4 seconds for the ball to come back down to the person who threw it up at that velocity. And by the way, 60 kilometers per hour is achievable by a human. Thanks for watching. See you next time.